Hi, in this lecture, I am going to talk about loop termination. While loop has the while loop continues as long as the condition is true, and with that, we can create a condition. For example, I can create a loop where user will indicate the end of input by entering a negative value, a sentinel value. We call that a sentinel value. For example, I have a prompt: enter an item or negative number when done. So user can enter positive number for like how much is spent today for each item, and when they enter negative number, that signal the program they have finished entering data, and the loop should terminate. And how do we do this? To do this, I would set a Boolean condition to false, and while not done, so done to false, while not done, this will be true, so the while loop will execute the first time. Of course, I have an accumulator total set to 0 initially. Um, the item equal to float input, so I prompt user for input, and if the item is greater than equal to 0, then I increment the accumulator. Otherwise, I set done to true. If when you set done to true, say the user enter -1, the next time you execute the loop, now while not done, while not true, which is false, the loop terminates, and then I will have the total. Let's look at this program in Repel it so you can see how this works. I already prepared this, so let me copy and paste into Repel it, and let me run the program. Let's say I spend 10, 20, 30, 40, 50, and -1. How much do I spend? Well, I spent $150 today, quite a lot. And I can run this program, say I spend $30, -1, I spend $30. It doesn't have a set number of loop. The condition happen inside the loop whether to terminate or not using the sentinel value. And then I set the flag to done when I see the sentinel value. Again, this is a flag control. The loop terminates when certain condition is met, and the loop always begin because I set done to false while not done. This is just a kind of like a pattern that people like to use: while not done, while not finished, loop continue. Again, can you identify the four parts of every loop? The initialization, total equals 0, done equals to false. Condition, while not done. Loop, inside the loop, the body. I prompt user for input. I check whether the input is greater than equal to 0. If not, I set the flag to true to execute, to terminate the loop. The four parts of every loop, as you can see in this while loop. When you look at this while loop here, you might thinking, well, the Boolean variable done may not be needed if I would set item to some initialized value so that I can get into the loop the first time. You can do that. I set item to equal to 99, and while item greater than equal to 99, the first thing I do is I overwrite item with the prompt. If item greater than equal to 0, then I update the total. If item is not greater than equal to 0, when you come back to the loop here, you will terminate the loop. This will work too. And again, since I already have this program, let me show you this in Repel it. And let me delete this and run this. I can run this, say, one time. I can run this, say, 10, 20, 30, 3 times, or however many times you want until you enter the sentinel value. So now you see how to do flat control and center now in program. Let's going back to our square root example that you have seen in the lecture in the past weeks. I will do like 10 times, but you have seen before the root did not change after certain times, after certain iteration. And instead of doing 10 times, it should stop when we have the right relative precision. In other words, between each successive calculation, if the change is only like so small, I don't really need to do any more. So I can change my square root function and using flat control. In this flat control, I check the this is the previous root and this is the current root. I check if the previous and the current one is less than epsilon. The epsilon is just like a delta. How much does it change in each successive iteration? If it's less than 1 times 10 to the minus 10, which is a very small number, then I set done equal to true to exit the loop and return the root. Let's see how this works. So I had this already, so let me copy and paste it and import math. Don't forget that. My square root, I'll say, I don't know, 50, 51023, and oops, and how about my square root of, say, 10,000, which is 100. Square root of 51023 is 225.88, and square root of 10,000 is 100. This loop will continue until the delta between the two iteration is less than 1 times 10 to the minus 10. Why relative error? Well, because this can't matter. I mean, 1 centimeter matter when you drill a hole, but 1 meter matter much less when you compute the distance between two large cities, right? 1 milligram matter for some drug, but 1 kilogram matter much less when you order like a ton of dirt, or 1 kilogram, or one, or a couple pound different. So let's do another program here. Write a program that prompts user to input a student exam grade. When user enters -1, it terminates the input, and the program calculates the average of all the grade enters and display the average. How do I find out? How do I calculate average? What information do you need to calculate average? To calculate average, you need to know the total grade and how many students. Can you find out total grade? What pattern we have learned you can use to find the total grade? And so let's build this program together. We're going to use the accumulator pattern, like the previous example has shown, to find the total. So let me remove this, and I could use a little bit more space here. So we now have an accumulator, so let's have a total equal to 0, and we're going to use a while loop. So let's just say done equal to false, and while not done. We can ask user for grade, enter grade, enter negative value when done. So if gray is greater than or equal to 0, then I increment the total. This is the accumulator method with the gray value. And if gray is not greater than or equal to 0, then I terminate the loop. So let's just print the total here. So this is an accumulator similar to the item that we did earlier. So let's run this first to see whether we can get the right total. Okay, enter. So let me move this a little bit over. Or maybe, how about this? Yeah. Somebody got 100%, 90%, 80%, and that's all for now. The total is 270. 100, 90, 80, you add together is 270. That's good. And I enter 3 gray. So how do I count how many gray I enter? I think I hear accumulator. You could have another accumulator to count how many students are there. How many students are there depends on how many grade you enter. So in this case, every time the user enter a grade greater than or equal to 0, you can also increment the counter, the count how many grade have entered. And let me print the count here to see whether this work. I enter 100, 90, 80, and minus 1. So 270 total and 3 grade I enter. I get that's good. So let's make this output look better. Print number of student, which is a counter, and print average. Now, how do we calculate the average? Well, the average is the total divided by how many students. I think I have a typo. Let's see. Oops. This one have a typo from and let's run this. Again, I do 100, 90, 80, minus 1. And now, number of students, 3. Average is 90. Or, I'm sorry, instead of number of students, that should be number of grades that will enter. So let's do this. Again, 100, 90, 80, and minus 1. So number of grades entered is 3. Average is 90. How about this one? The 3n plus 1 sequence is a very interesting sequence. It has a following condition. You start with the integer n. If n is even, divide by 2. If n is odd, multiply by 3 and add 1. Repeat this process with a new value n. Terminate when n equal to 1. So this is a 3n plus 1 sequence. So let's write a function called sequence 3np1 that take one parameter, integer n. The function displays the 3n plus 1 sequence number. This is a very interesting problem, and I want everybody to try this, given what we have learned in this while loop and a loop termination. See if you can do it, and I will reveal the answer during lecture.